Load balancing is the process of balancing incoming requests to multiple machines, processes, or services at the back end. In this video, we will explain two types of load balancer, the layer 4 and layer 7 load balancing approach. And we're going to talk about the pros and cons. We're going to talk about what are they first. Then we're going to talk about the pros and cons of each one of them, right? And we're going to show you an actual how to actually implement layer 4 and layer 7 load balancers, okay, using HAPROXY. It's an open source proxy that allows you, we talked about proxy, a concept. Load balancer is nothing but a proxy. It is a reverse proxy. We talked about that in another video. I'm going to reference it here. Reverse proxy versus proxy, what are the differences? But if you're here, you want to learn about these two differences, then you're in the right place. If you're new here, welcome. My name is Hussein, and in this channel we discuss all sorts of software engineering videos and tutorials by example. So if you want to become a better software engineer, consider subscribing, hit that bell icon, and like this video if you like it. With that said, let's just jump into this video, guys. All right, this is the agenda. We're going to talk about what is first layer 4 and what is layer 7, and we have made a very detailed video about all these 7 layers on the OSI model layers, right? So I explained that in a view of the software engineering view of these layers, right? Not a network engineer, which goes into the details and actual packets and headers of all these layers, right? As a software engineer, we really care about what really happens in each layer, and then I try to do that. And then so I'm going to reference that video, OSI model. Okay, we're going to talk about that here in a minute. Just a TLDR, load balancer. We're going to talk about what is a load balancer, right? Before we jump into layer 4 or layer 7, you probably know if you're into this video, but it's not nothing. It doesn't hurt to repeat, obviously, guys. The more we repeat things, we learn more. Okay, that's necessary. That's obviously the case for me. I like to repeat things if I want to learn things. Okay, layer 4 load balancer. We're going to talk about what is a layer 4 load balancer, pros and cons. I'm going to talk about we're going to show you an example how it looks like, what it actually does, right? An implementation. We're going to share the source code about and all that stuff, guys, so don't worry about it. Layer 7 load balancer. We're going to talk about the pros and cons of that. All right, guys. So what is layer 4? What is layer 7? What is all that stuff, right? So we talked that if you watch the OSI model, you're gonna we go dive deep into each of those layers. But essentially, in a nutshell, these are the 7 layers that we have. The physical layer, where everything is ones and zeros. We try to sneak in bits into this physical medium, whether this is radio wave through Wi-Fi or fiber optics or Ethernet cables, electric Ethernet cables, right? Then we have the data link, an actual, some logical frames are built here. There's a MAC address is here, and there is a layer 3, which is an interesting layer where we start making sense of the IP addresses here, and layer 4, which has a higher level transmission protocol, which is called the TCP and UDP. We talked about that video. I'm gonna reference it here. What is the difference between TCP and UDP? But we know the ports here, okay? We know the ports, and these 2 layers are always intertwined. They are usually together, okay? When you say layer 4, we really mean layer 4 and 3, okay? So at this layer, we know that stuff. Layer 5 and layer 6, I'm not gonna talk about it, but it's just as an overview here. Layer 7 is actually where application works. Like, this is your HTTP, this is your SMTP, this is your XMTP, whatever. That essentially, that's what you make a GET request on a specific port. You get headers, cookies, content type, all this text, right? And that is essentially layer 7. You have access to these data here. But however, layer 4, you only see IP addresses and ports, okay? That's what you really need to know, okay? Layer load balancer, what is that? Or sometimes it's called fault tolerant software, and essentially it's a software that you built into and hosted into a machine or a service or a VM or a container. What it does is the client connects to the load balancer, and it decides based on a lot of criteria where to forward this request to. whether to forward this to server 1 or whether to forward to server 2. That's essentially what load balancer is, okay? So if you have like 1,000 users, you don't want to always forward them to one machine because this machine will run out of socks, right? TCP connections, and it will die, all right? And another option is if this machine died, you want to reverse the direction to go to a machine that essentially is available, right? So this is the load balancer in a nutshell, but there's so much to it, okay? And this is what we're going to talk about here. There are two types of load balancer. Layer 4 load balancer, and we talked about layer 4, where we only know the IP and the port, okay? That's what you need to know. At layer 4, these are the two pieces that you know. You don't know the data. You know there is a data, it's a part of the data segment, but you can't dare and look at it because it doesn't make any sense to do that. Sometimes it is encrypted using TLS, sometimes it is scrambled, sometimes it's compressed, so it doesn't really make any sense to look at the data through the TCP layer, okay? So we don't do that at all. Okay, but essentially what you do is a layer 4 load balancer looks at the IP address and sometimes the port if you want to, and makes a decision based on that. Okay, so let's make a request. Let's say it's a very simple TCP request, and it's coming from, it goes to the this load balancer, the reverse proxy. So there is one connection that has just established here, and what it does is, okay, it says, okay, I am going to you, sir. Okay, this is coming from me. This is the IP address, and this is the data. And this load balancer looks at that thing only, okay? And so, okay, you want to go to me. I know myself as a layer 4 load balancer, so I'm going to look at that. What you really want to go is either this machine or this machine, right? So what it does, it makes certain smart choices based on the algorithm that is defined on the load balancer software. There is round robin, which means one by one, it will just round robin through the request. There is another algorithm called least connection. There's other algorithm as well. But essentially, picks a server, could be randomly, it could be round robin, and literally change the IP address underneath the target to that IP address. And how it does that, essentially using network address translation, okay? And this is very critical, guys. And what happens here is it keeps a table where, okay, I changed the source from me to 44333, okay? And that's what I did, and it keeps an entry. And we talked about network address translation. I'm going to reference that video there, okay? You go look at it. Essentially, well, that's what it does. But here's the trick. This is one connection, guys. This is one TCP connection. As far as this guy concerned, nothing happened, okay? It didn't know that it was forwarded to that. And that's why it's called reverse proxy, because the client doesn't know which server it was connected to, right? Whereas the proxy, the server doesn't know which client it is coming from, okay? So that's the difference between a reverse proxy and a proxy in a nutshell, okay? Some people can disagree with that. We can talk about it because there are some proxies add headers that tells the server which client originated that request. But in a nutshell, at that level, at layer 4, you don't know, okay? Layer 7, might be. All right, so that's essentially what happens, right? Take the request, boo, goes to that thing, and that's it, okay? It changed that request, all right? Also change, obviously, where it is coming from. It doesn't leave the 4111 to this because this guy doesn't know how to talk back to the client, okay? It knows how to talk back to the proxy because sometimes it's a different subnet, the whole thing, right? It could be a completely different zone, okay? So you need to really just give it yourself, okay? And layer 4, pros and cons. What's good, what's not good about this, okay? So it looks at the IP, and that's it. It just changed the IP address. So it can look at what? It can look at latency. It checks if the server is up and down, and that's it, right? And it looks like how fast this server is responding and makes a decision based on that. So let's look at the pros here. The pros is it's simpler, right? Because it literally looks at the IP and the port, and it's right there. It doesn't need to look at the data. So it's a very simple load balancing. It's also efficient because we don't need to look at the data. So it's faster, right? Okay. This is debatable, okay? with Cant technology, but how fast compared to layer 7? But it is faster nonetheless, right? Especially it doesn't need to decrypt and all that stuff. It doesn't look at the data at all. So it looks at the IP and the port. And it is kind of, I added that. I didn't see it anywhere, but I believe it is more secure. And the reason for my belief that is this, it's more secure is layer 7, and we're going to come to that layer 7. Layer 7 needs to look at the data. So it actually, if it's HTTPS, it needs to decrypt it. So it needs to have the certificate. So if the load balancer got compromised, right, all the data is essentially available for the hacker. But if the load balancer, therefore load balancer got compromised, nobody can gain anything out of it, okay? Because it's still just packets that are encrypted. Even the load balancer doesn't know what's in content of this data, right? So that's, to me, more balancer. It's more secure. You can disagree with that. Leave it in the comment. I would love you have to have a debate and talk about this, because that's where we are. We're a software engineer. We discuss, right? Okay, we cannot just assume everything is just final, right, guys? One TCP connection, we talked about that, and it's very critical to know that this is one TCP connection, right? And it's like connecting to your router and eventually to google.com, right? There is one TCP connection between you and Google, but the router routes that TCP connection through multiple routers, but essentially there is one pipe, not really pipe, circuit, if you will, between the destination and the source, right? It doesn't, the load balancer doesn't terminate the TLS. It says, okay, no, you connect to me, sir. You do not see anyone else, okay? So we kind of forward, this is a one TCP connection, and it's critical. So that's kind of more efficient, right? So one TCP connection. It's list management. And it uses NAT. I don't know if this is a pros or cons, but this kind of statefulness there, right, when you use NAT. Cons, what's bad about this? There's no smart load balancing. So what does that mean? If you can't look at the data, you cannot make smart decisions based on the data. Like, that means you cannot look at the cookies. That means you cannot change anything in the headers if you're using HTTP load balancers. You cannot modify, you cannot rewrite URLs, right? Like saying, okay, if you go to slash, you know these affiliate links, like I go hussein.com/NordVPN, right? And if someone goes to that, rewrite the URL to go to some other URL. You cannot do this with a layer 4 load balancer, because you have no idea what the path is. The only thing you know is the IP. You cannot do anything else, okay? So that's a kind of cons, and it's a big cons, right? It's not applicable for microservices. Microservices, essentially, when you go to a specific load balancer, the ingress protocol can use the content to forward to different services based on the path. Like if you go to like Instagram, let's assume Instagram uses microservices. I believe they do. But if you go to a REST endpoint called /pictures, it will take you to a complete service that is dedicated for pictures and media and data and blob storage, right? So it goes to that. It knows how to cache. It knows a lot of things, right? Versus if you go to an endpoint /comments, same load balancer, it takes you to a completely different service, completely different set of service. Another team is managing that service, right? So /comments, for example, is managing the comment. Could be a different database altogether. We talked about microservices, right? Another video. I'm going to reference it here if you guys are interested. Sticky per segment, again, this is something I added, and this is very critical. You don't really need to know that, but to me, I had to think about it really hard about this. That's what she said. And what happens is when you forward, you make a TCP connection. There is a maximum transmission unit that you can send, like 1500 bytes, right? And if your GET request is, I don't know, a meg, then you need to break that into multiple TCP segments. So it's one packet, multiple segments. But guess what? This load balancer better forward all those segments to the same destination. You cannot forward part of the packet to one server and another part of the segment another server, that will be disaster, right? So you might say, oh, the load balancer take care of this, so why you're adding this? I don't know. I just like to think about details. Sometimes I might be wrong, but it has to be sticky. So sometimes the implementation of the load balancer have to be smart enough to all the segments that belong to a single packet ID you forward to one server. I don't know why I added it to the cons section, but I just want to mention it. Okay, no caching, because I cannot look at that data. I cannot cache it, sir. I cannot do anything, right? How can I cache? Right? Caching is essentially, guys, like if you make a request to Hussein Nasser / index.html and another user, and you made it for some reason, your app made the request again. I already fetched that. I contacted the backend service. I am gonna cache it at the load balancer level. So, and a lot of CDNs like Cloudflare does that all the time, right? Caching, because they're using layer 7. They know what's the content of this. They can actually take that file, copy it somewhere, and look at the data. Hey, you were just requested that file because it's /index.html, which is part of layer 7, right? You need to look at the content. All right, guys, let's do a demo showing you a layer 4 load balancer using HAPROXY. How about that? All right, guys, here I have an Express Node.js application that does literally nothing. It just listens to a port that I gave it, say listen to port 5555, and then when I visit literally anything on that page or that service or that web server, just tell me which port are you listening to. Okay, it's useless, but it's very useful. What the heck does that mean? Okay, it is useless as an application. It's useful for us to show the load balancing. Okay, so let's actually run this application, show you what this means. Okay, it's literally listens to a port, and then if you visit, it tells you, hey, you were served by 5555 or whatever. Okay, so here's what I'm gonna do. I'm gonna run this application on port 5555, and I'm gonna run the application on port 4444. Okay. And then I'm gonna go to Chrome and then literally type HTTP localhost 5555, and you can see I am served by 5555. Okay, and when I go to port 4444, you can say that's 444. Okay, what does that mean? Now, while I'm doing that, what I'm gonna do is here now spin up a load balancer using HAPROXY. Okay, and then listen to a different port, maybe 80, maybe another port, and then literally forward the load between those two using the layer 4 load balancer, okay, using the TCP. So how do we do that? First of all, you need to install HAPROXY, okay? To install HAPROXY in Mac, you do brew install HAPROXY. On Windows, you go download that thing and essentially run it, okay? But we don't want to run it as a service because I want to configure that, okay? So once you install it, I have already installed it here on my machine. If you don't have Brew, just download Homebrew for Mac. I think this is the best way to install stuff in your Mac or Windows. But essentially, once you have an HAPROXY, you can run it and give it a configuration to consume. Okay, and let's take a look at the configuration here. Okay, I'm not gonna go into and write my own configuration from scratch. I have already done that, and here's my tcp.config, which is the layer 4 configuration here. And what I want to do is, there are 4 parts of the configuration. This is not an HAPROXY tutorial video, so I'm gonna skim through that. Maybe I'm gonna make another video just dedicated for HAPROXY. Leave a comment below if you really want to see that video. Okay, I'll add it to my list of videos to make. And essentially what it says, okay, specify how maximum number of connections. You cannot just exceed things, right? And then this is what I want to talk about here. So this timeout is the client and server. This doesn't make sense in a layer 4 load balancer, because these are identical, because we're using one TCP connection. And you're using a layer 7, that it makes sense because you have a TCP connection between this client and the load balancer, and then there is another TCP connection between the load balancer and the server. We're going to talk about that. But here's what I want to do. I want to listen to port 8888, okay, on the load balancer, okay? And the default backends for the load balancer are two servers, server 1 and server 2. Therefore, server 1 is listening on port 4444, and server 2 is listening on port 5555. Since it's all the whole thing is on my machine, that's why I'm using the loopback. If it's in a different machine, you're going to specify the IP address. So let's run this thing and see what happens. I'm going to do... this is ls showing you the TCP. So I'm going to do HAPROXY-F, that means file, tcp.cfg, config, okay? And it looks like it's running, okay? Remember, also I have two applications running now, right? Now if I go to 5555, this is running, 4444, this is running. If I go to localhost 8888, it will now forward me based on the current load balancing scheme, which is, I think, default is round robin, to 4444. Happens to be port 4444. Okay, I'm tired of saying 4444. Okay, all right. No matter how long I refresh, I cannot control this. It's all controlled by the load balancer. But what I can do is I can kill 4444. Okay, and see if it will actually tells me, hey, I'm gonna take you to 5555 because 4444 is, oh my god, that's funny, because 4444 is dead. Let's kill 4444. Okay, and then refresh, right, and see. Look at that. Took it a minute, but it just immediately refreshed now to 5555. But let's look at the proxy here. Look at that. It actually gives you some information. Server node, server 1 is down, right? Layer 4 connection problem, okay? So it actually detects, HAPROXY detects that, hey, you just killed server 1, right? So I cannot forward people there, okay? So here's what you do essentially. So if you spin it back up, on 4444, then you can essentially get it back, right? But it's now sticky at 5555 for some reason, okay? That's it. So we can't really control it, but it gives you some sort of a load balancer, as we saw, okay? So that's a layer 4 load balancer, guys. So let's jump back in. All right, guys, let's talk about, we talked about layer 4 load balancer. We showed you an example of how it looks like. Let's talk about layer 7 load balancer. This is actually fancier. But let's consider this. Okay, this is a layer 7 load balancer. What it actually means is it operates at the layer 7. That means it can see the application data. It is authorized to see that stuff. It is authorized to decrypt. If you told it to, okay, it's gonna establish a TLS connection between you and the client. What does that mean? Between the client and this load balancer, gives you the certificate of the load balancer, and it can decrypt your stuff. Okay, it can look at your stuff and it can make decision. If it's HTTP, it can just look through that stuff. Okay, and then what happens is it will make decision based on that. So what I'm gonna do here is I have this microservices example here where I have an IP address here, service dedicated just for serving pictures. Voice notes on WhatsApp, pictures on WhatsApp or Instagram, wherever, right? I have a dedicated server. It has a higher bandwidth, maybe. It has, I don't know, more processor power, has compression, has caching, all that kind of stuff. And this guy, maybe this is hosted on S3. This guy, just for comments, stores numbers and the strings, which is the comments. Maybe we're using MongoDB or a Postgres database here, okay? But the client talks to one server, the one load balancer, okay? I don't know if we're gonna call this load balancer here, but it acts like more like a reverse proxy ingress. But it's the same concept, right? You can still load balance things based on the picture here. So what I'm gonna do, the client will make a TCP connection between itself and the load balancer, and then what the essentially says, okay, I'm coming from me, going to you, sir. I want to get pictures. Give me all the pictures, and it doesn't obviously exist here, right? This get request. So now it will actually look at the data and say, oh, and there's a rule says, okay, if slash pictures, then forward to this set of nodes. And it could be one machine, could be 7 machines, all right, guys? And then it could pick load balancer between these machines. And it says, okay, wait a minute. Okay, you want to go there? I'm going to stop you there. This is me and you. This is one TCP connection. I'm going to establish a connection between myself and the server that you want to communicate to. So it's going to create a new TCP packet, forward that stuff to that server 44333 and coming from that. So again, the server doesn't know which client is coming from. It might even change the headers. It might actually add more headers. It might just modify the content because it owns it, because it can look at it, because it has full access to all that content, if obviously it can decrypt it, okay, which it can. And so what you see here is actually 2 TCP connections, okay? This could be secured TLS, right? So the TLS handshake should be happening here. And if you decided to have TLS at the back end, which you should in case of a cloud application. Some of you guys noted that in my previous video. Yes, I said that you don't have to encrypt at the back end, but it's a good idea to encrypt it. Obviously, you're adding the overhead of encrypting and decrypting, but essentially that boop, 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 that's 2 connections, okay? And then you get a picture, you're gonna forward to the picture. So what happens if I want to go to the comments? Well, it looks at the rules, find the rules that you're going to comment, establishes a connection with the guy 4444 from 2, and then just forward the connections, right? Gets the response, get back the results, and then forward it back to the client. So it maintains 2 connections and takes the data, re-encrypted with the new TLS certificate, and then pass it in, not necessarily, the symmetric key, and then pass it to the client. So it does decryption, encryption, decryption, encryption. It does a lot of stuff, but it gives you huge benefits, okay? Let's talk about pros and cons, guys. Pros and cons. Pros, what's good about this? Well, smart load balancing. We can do a lot of smart load balancing. We can do all this microservices stuff. We can look at the data and make decisions based on the data and forward the data based on certain logic, right? On the headers, which is pretty powerful if you ask me. It can do caching! Yes, it can do caching. Because now I know you are requesting /index.html. I know that I keep this stuff cached, handy dandy on my machine. I'm gonna serve it to you because I look at the data. I look. And then it's great for microservices as we showed. And cons. What's the bad thing about this? Is there something bad about this? Well, it is expensive. It looks at the data. Again, guys, you can argue with me. A lot of people say, even in Nginx and their website said, yes, it's more expensive, but it is almost insignificant because our machines are very powerful stuff, and just doing extra encryption or decryption is nothing to it, right? And looking at the data, right, parsing the data, that's not much. Okay, it's maybe a few cycles more, but nevertheless, it is more expensive. If you're using a Raspberry Pi as a layer 4 load balancer versus layer 7, you can see the difference. It decrypts, as we said, it terminates TLS if it has one. It decrypts the data, so it sends the client back the certificate of the load balancer. So it might use a server name indication here to serve different connections, right? Different certificates, right? Especially if you're having multiple domains going through that, right? Because users can actually like go to about.example.com or example.com or www.example.com. If you have multiple domains, you can go to the same IP but serve different certificates. You can do it here. because you are essentially the terminator. You terminate TLS. It has two TCP connections. Okay. Um, Pros and cons. Obviously, it's less secure, in my opinion, again, because it just looks through your stuff, and maybe you're not comfortable that the load balancer looks at your data. Some people don't, right? Right. Some people are paranoid that, hey, I don't want the load balancer to look at my data. I want it to be a dumb layer 4 load balancer. Okay. Two TCP connections, obviously. So which means more, which it could be a good thing or a bad thing, in my opinion, right? A bad thing because more connections, you have to believe it persisted, right? That means these timeouts are very critical, right? Especially if you're using layer 4 load balancer versus one timeout. But with these TCP connections, you can use, I don't know if layer 7 load balancer like Nginx or HAPROXY does that, but I would imagine sharing different clients with the same TCP connection at the backend, because they don't care as long as you can send data through the same connection. Why do you care, right? So I would pool these connections. If I would implement this. I would pool these TCP connections, and if I would serve by 100 clients, I could use 3 connections to serve at the backend to serve all these 100 clients, right? But I might be wrong. Okay, I never implemented a proxy before, so I might be wrong, right? Again, guys, correct me if I'm wrong, if I'm saying BS stuff. Must share the TLS certificate. We talked about that. If you don't trust the load balancer, you don't have choice. You have to share that certificate. All right, guys, let's show an example. Using HAPROXY. All right, guys, let's take a look at the HTTP layer 7 proxy. A little bit more stuff here, but essentially it's kind of similar. You want this to be kind of different, the client and server, but look at the mood here. That's the difference. The mood is HTTP, right? Which is the layer 7 load balancer. That's the most important thing. If you look at the TCP, which is something we didn't talk about, but the mood is TCP, which is layer 4. That's what the operator. So we're operating at the layer 7 load balancer. What I want to do here, I want to listen on port 9999, right? And then obviously the mode is HTTP. This is redundant. We can just inherit from the default. Okay. And here's what I want to do. Okay. Access control layer, I want to use app1 if someone goes to /app1, okay? This could be our media thing, okay? And if I want to go to app2, right, I want to use the app2. And based on that, I'm going to use different backend servers based on that decision. So to be honest, Nginx is way much simpler than that, right? We did a video on Nginx. I'm going to reference it here. It is so much simpler layer 7 load balancer, in my opinion. It uses just this last location and then that's it. Okay, it's like you have to do an if statement and all that stuff. It's ugly, right? But that's my point. But if I go to app1, I want you to go to app1 servers, which are 444 and 555. If I go to app2, I want you to go to app 6666 and 777, and I have them all spun up, right? Just 777 and 555 and 4444. Just for fanciness, I'm not gonna spin 6666. Okay, and we're gonna see what happens, right? So HAPROXY, the file is now http.cfg, and we are getting log format ignore since it has no log address. No problem. We're gonna ignore that stuff. It tells you that HTTP2 server 1 is down because there is no 6666. That's okay. That's okay. Let's see what will happen. So we listened to what port, guys? 9999. Was that the port that we listened to? Yes, 9999. So let's go to Chrome. And now let's say, as you can see, layer 4444 gives you this. This is 5 and this is 7. Okay. And if I do localhost 9999, I'm gonna get an error because you actually told it to give it only on path, right? So you have to say either app1 or app2, right? That's why the load balancer returned that error for you. Okay, if you do app1, then you go to either 444 or 5. Okay, and look at that, it's actually bouncing this time, right? That's actually better. Okay, that's because we're using HTTP load balancer. We kind of not as sticky as a layer 4 load balancer. I see age request is this is literally round robin now. Okay, we're round robining. Okay, are we round? Did we specify round robin? I don't think we did, but I think that's the default one. So we'll round robin around these things. I can't see it here, but I think the default is round robin. So that's actually, see, layer 7 for some reason can make that decision to use round robin in layer 7 versus TCP. It kind of really scared to do round robin because of the stickiness that we talked about, right? The segments and all that stuff. So if it comes from a source IP, it always forwards it to a certain IP, and it just makes sure that is always the case because it's a single TCP connection. Once you close the connection, you're gonna get forwarded to somewhere else. Okay, and app2, I'm going to 7.7, and there is no obviously on-ramp because there's just one server. All right, let's spin up. In this case, let's spin up port 7778. Okay, and let's say, I don't know, node index.js. So now I'm listening to 7778, but I want to change my proxy here to, instead of 6666, or keep it there, I'm going to add another service here. Okay, server 3. And this is 7776. Is that the port that we're listening? 7778. Okay, I want you to go to 8 as well. Okay, and now go back to my HAPROXY, kill it, and spin it up again. And now let's try it out. Now if I go 9999, you can see beep, 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 or round robin, round robin, round robin. Look at that, look at that. Go to app 1, we're round robining between those two. Isn't that fun, guys? Tell me to stop, please. Tell me to stop. Oh, thank you. Okay, I was having so much fun. All right, guys. All right. So what do? We discussed layer 4, layer 7. We showed demos, right? We talked about what a load balancer is. We talked about what a layer 4 and layer 7 is. We talked about what just a load balancer is. We showed you a layer 4 load balancer. We showed you pros and cons. We showed you a layer 7 load balancer. We showed you the pros and cons. All right. Okay. I hope you enjoyed this video. Give it a like, share it with your friends, and if you want to become a better software engineer, consider subscribing, hit that bell icon, hit that like button, and we're gonna see you on the next one. You guys stay awesome.